All right, so on the first day of this chapter, we talked about average value, and we looked at these three graphs. I'm going to kind of scroll so you can see the other graph. We looked at these three graphs, and we were able to determine what the average value was. And if you remember, even at the end of class, we came up with a way to figure out no matter what the graph was. And we started the process, or at least I wanted your brains kind of starting to link the process between what we were doing with Riemann sums and what this lesson was all about, which is called average value. And today, my whole goal is that you will understand average value in a deeper way. And if you recall, I believe it was Ben and Ryan were both especially came up with the ideas that what you had to do was you were going to find the area and then you were going to divide by the length of the interval. And that was what we came up with as almost like a quick way of dealing with average, we'll call it AG, value. So I want you to look at this next screen here. I'm going to flip to this next screen, and not to be too overwhelmed, but I want you to think about what you see there. It says average value, and then it has this 1 over b minus a, has the integral sign, a to b, f of x dx. Take a moment, look at that. Pause if you need to. But I want you to think through, what exactly is this saying? What do we know that s, or the integral symbol, actually means? What does this mean? This is actually representing the area from A to B, right? And what do you suppose this represents? This is the part that we were just saying, divided by the length of the interval. This is the formal way, or the more formal way, of interpreting average value. Area from A to B divided by the length of the interval, A to B. That's what that is actually intending on teaching you or showing you. So that is the mathematical way of expressing the same thing that you did already. Now looking at this next part, it says find the value from -3 to 0 and the square root of 9 minus x squared. Now I want you to think about that, because that graph in and of itself, up to this point in this year, this school year, we haven't even done any kind of integrals or tricks to how to find the area, but I need you to do that. So what shape, what graph would this be? Hopefully you recognize this as being a half a circle. This is a half a circle with a radius of how much? Good, 3. Now what this is asking for, though, is from -3 to 0. So it wants this section of that circle. We know the area of a circle is pi r squared, and so that means it's going to be 9 pi would be the whole circle, and so this area would actually be 9 pi over 4. Are we good with that? All right, if it asks for the average value, the difference would be then that I would take the area divided by the length of the interval. So I'm going to do 9 pi over 4, that's just the area, and the length of that interval, -3 to 0, is 3. Obviously the answer wouldn't be left as that, and so maybe you need to see it as, okay, we've got that fraction and keep, change, and flip, or maybe you can do this just automatically, understanding that it's 9 pi over 12, or maybe even better, you recognize that the 3 divides into that, giving me 3 pi over 4. And that's the answer that I'm looking for. Let's do the next one. The next example here says the integral from 2 to 7 of x minus 5. What does that shape or graph look like? That's a line. Good. With a y-intercept of what? Yep. And an x-intercept of? Wonderful. So here's my graph. This is asking from 2 to 7. So I'm going to use from 2 to 7. All right, so I'm going to find the area of the section. And so this is 3, and this is also 3. That's 9 halves right there. This is 2 by 2, or rather inside here is 2. So again, remember that 9 halves is below. And rather than me writing that as 2, I'm going to write it as 4 halves, so we can see this relatively quickly. So then I get -5 halves. That's my area. Are we good with that? Ooh, now to change things up a little bit, you see an absolute value sign. What does that mean to do? That means that my graph just bounced. And so instead of it being negative 9 halves there, it's going to be 9 halves plus 4 halves. That would give me 13 halves. Any questions about that? If so, please feel free to write that down in your notes. If this is an area that we need to go back over so that tomorrow when we get into class, I can actually address that. But that would be the area of the absolute value of x minus 5 from 2 to 7. Now the average value, again, notice this doesn't have the absolute value sign, so we're going to use that one in third part there, number 3, and that area was negative 5 halves divided by the length of the interval, which is 5. Again, if you want me to show you, keep, change, and flip, and you get negative 1/2 as your average value for that section. Okay? And that's really the average value lesson. It really isn't intended to be too lengthy today, but I just wanted to kind of recap and how that looks with just the integral notation without actually looking at just straight lines, but how we can even do it with circles. Certainly, eventually, it'll be even parabolas and all kinds of polynomials. So, okay, we'll see you tomorrow.